Hello everyone, welcome to my channel Chemistry is Fun. Today I'll continue with the topic of atomic structure. So today's video is atomic structure part 2, NEET 2024. Now we will see something about hydrogen spectrum today. Now when an electric discharge is passed through hydrogen gas at a low pressure, a bluish light will be emitted. And when a ray of this light is passed through a prism, we will get a discontinuous line spectrum. In that, there will be several isolated sharp lines. The wavelengths of these various lines show that these lines will lie in visible, ultraviolet and infrared regions. Now, all these lines can be divided into some spectral series, which I have listed here. One is the Lyman series, which lies in ultraviolet region. Now for this series, for Lyman series, value for N1 is 1. This is N1 value. And these are the values of N2. For Lyman series which lies in ultraviolet region, N1 value is 1. N2 value can be 2, 3, 4, 5 or anything. So here these integers are such that N2 should be greater than N1. For all these given spectral series, N1 will remain constant, N2 will vary from line to line in the same series. For the Lyman series, N1 should be 1, N2 can be 2, 3, 4 or something else. N1 for Balmer series is 2. So for Lyman, N1 is 1. For Balmer series, which is in the visible region, N1 value is 2, N2 value can be 3, 4, 5 or anything else. For the Paschen series, N1 value will be 3, N2 value can be 4, 5, 6. For bracket series, N1 value can be 4, N2 values can be 5, 6 or 7. And for the Fund series, we will find that Paschen, bracket and Fund, they all lie in the IR region. For the Fund series, N1 value is 5, whereas N2 values are 6, 7, 8. This is for revision, so we are discussing in short because I know that you have already gone through all this. Just for a quick revision, I am giving you these points and I think it will help you. Now for all these, Reitz has presented a mathematical formula to find the wavelength of various series. We can use this formula: 1 by lambda is equal to nu bar r into 1 by n square minus 1 by n1 square minus 1 by n2 square, where r is Rydberg constant whose value is 109678 centimeter inverse. So N1 and N2 we know. For different series we will get, just now we have seen N1 and N2 values are different. Okay, so like that we can find out the wavelengths using this equation. Balmer series consists of 4 prominent lines. The Balmer equation will be 1 by lambda equal to r into 1 by 2 square minus 1 by n square, because students, you see, in this basic equation it is r into 1 by n1 square, and for Balmer n1, for Lyman n1 is 1, for Balmer n1 is 2. For Balmer n1 is 2, so we put here 2. So for Balmer equation will be 1 by lambda equal to r into 1 by 2 square minus 1 by n square, where n value will be more than 2, that is 3, 4, 5, 6. I just go back here once again. Balmer series in the visible region, you see N1 value is 2. N2 values can be anything from 3, 4, 5 onwards. So N1 equal to 2 if we put here, we get 1 by lambda equal to r into 1 by 2 square minus 1 by n square, where n values can be 3, 4, 5 or 6. The Rydberg formula is used to calculate wavelength of any line of the spectrum. that is 1 by lambda is equal to Rz square. Z is what? Atomic number. Z is atomic number. 1 by lambda equal to Rz square into 1 by n1 square minus 1 by n1 plus x whole square, where x is the number of lines in the spectrum. X refers to number of lines in the spectrum. So with this formula we can calculate if numericals come. X is number of lines in the spectrum. Now see, if the transition of electron is taking place from a N2 shell to N1 shell, let's say from N2 shell to N1 shell it is coming, then number of lines can be given by this formula, N2 minus N1 into N2 minus N1 plus 1 divided by 2. So N2 minus N1, where the transition is taking place from N2, it is going to N1 shell. So it will be N2 minus N1 into N2 minus N1 plus 1 divided by 2. So with this we can calculate the number of lines. And here we have stated that x is the number of lines in this formula. So using both these formulas we can calculate the numericals. Next is Bohr's atomic model. There are some main postulates. The electrons revolve round the nucleus in circular path of fixed energy, called the stationary states. Electrons revolve in stationary states. Electrons revolve round the nucleus in circular path. They have a fixed energy and these are known as the stationary states. The angular momentum of the electrons are quantized, so there will be a particular value only. So mvr will be equal to nh by 2 pi, okay, where n is the orbit number, r is radius of the orbit, and m and v are mass and velocity for the electrons. So with this we can calculate, and we find from here that the energy and angular momentum is quantized for the electrons. Energy and angular momentum is quantized for the electrons. From the Bohr's atomic model, we get some important formulations, because these are for single electron species like hydrogen, He plus, Li2 plus, Be3 plus, these all are single electron species. We find that greater the distance from the nucleus, more is the energy. So E1 is less than E2, less than E3, less than E4. So as we go out, as we move out from the nucleus, greater distance means more energy associated with that. Next, if we see the energy gap between E1 and E2, that is E2 minus E1, that is greater than the difference in energy between E3 and E2. This is greater than the difference in energy between E4 and E3. Next is, we can calculate radius of the Bohr orbit of electrons by using the formula r equal to n square by z into 0.529 angstrom. R equal to n square by z into 0.529 angstrom, where r is radius of the Bohr orbit of electrons. Next is, energy of the electrons can be calculated by E equal to minus z square by n square into 21.79 into 10 to the power minus 19 joule per atom, minus z square by n square into 21.79 into 10 to the power minus 19 joules per atom. With this we can calculate energy of electrons. I will continue with this topic in my next video also, and we will try to solve out some of the numericals. I hope these points will help you in the exam. Thanks for watching my video. Please subscribe to my channel. Thanks for watching. Thank you all.